All right, here's example 4. We're trying to find the intervals where the function is increasing and decreasing, finding our local maximums and minimums, finding out if they are local maximums or local minimums. So let's take a look at our intervals. We got our f, we got our f prime. I'm going to encourage you to find what are our critical values where that equals 0. So we could also say, if I divide by 2 and move this over to the other side, when does x times eight x plus 3 equal 3? Or what you could do is you could graph this and find the zeros. That's another option. It's probably the quickest way to do it. And if you graph this and find your zeros with your calculator, you're going to get x equals 0.55185. So I want to know what's going on to the left of 0.55185 and what's going on to the right of 0.55185. So you need to tell me if I plug in any number to the left or to the right of that, what's happening? What's your f prime value? What's happening to f? And is it a max or a minimum? So please take a second, pause the video, try it, and then unpause to check your work. All right, so f prime, if I plug in an f prime value of let's say 0. If I plug in a 0, 0 is easy. If I say x equals 0 for this f prime, well, that's 0 and 0, that's negative 6. So it's a negative value, which means I've got a negative slope, which means I'm decreasing. And if I plug in, let's say 2, I get 16 times 8, which is 80 plus 48, 128 plus 48 minus 6. That's going to be a positive number, which means I'm increasing. So if I went from decreasing to increasing, I went from going down to going up, decreasing to increasing, that must be a minimum value. All right, let's check example 2 and example 3, and then we'll get one more video for the last part. So example 2, we're going to take the same process. Here I've got to be careful about my my function. I have to take into account where is f prime undefined. So interval, what's going on with f prime, what's going on with f, and is it a max or a minimum value? So let's look at our derivative. Low d high, high d low, square the bottom. There you go. So if I take the derivative of x squared over x squared plus 3, what I'm going to get is f prime equals, it's going to be 6x over x squared plus 3 squared. All right, I need to figure out what are my critical points, where is this equal to 0, and then once I've got where that's equal to 0, then I can find my intervals. So let's see, if I got 6x over x squared plus 3 squared equals 0, then I could either solve it or use my calculator, or I can cheat a little bit here. I can see that the derivative is 0 at 0. So the only value where it's 0 is at 0, and it is defined and continuous over the entire domain. So we only got to think about x equals 0 there. So I only got to think about x equals 0. Then I need to know what's going on to the left is 0, what's going on to the right is 0. I'm going to ask you to take a minute, try that one, pause the video, and then unpause and check your work when you're done. All right, so if I plug in let's say a -1, if I say x equals -1, well, I'm going to get, for f prime, I'm going to get a -6 over a positive number because it's squared on the bottom. So -6 over positive, that's a negative, which means f is decreasing. If I plug in, let's say x equals +1, I'm going to get 1 over 16, or not 1 over 16, 6 over 16, which is still positive, but it's increasing. So what do I have then? If I went from decreasing to increasing, that means I have a local minimum. All right. Please try 3 on your own, and then check the answer key in the Google Classroom completed notes PDF when you're done.